Greetings, everyone. The automobile of today is undergoing massive transformation from a product that is mainly hardware based to a software centric electronic device on wheels. From the mechanical features of horsepower and torque to technological features defined by software for convenience, safety, or other intelligent connectivity solutions, consumer from vehicles have undergone quite a change. Driven by the mega trends of electrification, automation, connectivity, and shared mobility that are reshaping customer expectations, vehicle manufacturers are increasingly turning to software to address them. Most premium vehicles today, in fact, run on over 100 million lines of software code. In fact, mass market vehicles are not too far behind. Software will become the critical tipping point in the auto industry, while OEMs and tier one suppliers look to capture business in this software-driven value chain. It is not for nothing that manufacturers and suppliers globally are vigorously expanding their internal software R&D teams to reduce the cost of software outsourcing. In such a scenario, as software becomes more and more complex, it is pertinent to understand the developments in the domain of software-defined vehicles. But today is not just shaping the customer experience, but is also shaping the specification of the hardware in vehicles. In the process of this evolution, it is to the creation of new business models and new types of collaborations. How are automakers in India preparing for the software-defined vehicle of tomorrow? What is the level of commitment the industry is willing to make towards in-house development of software, or would they prefer to have closer partnerships with software companies and tier one suppliers? How are our R&D leaders looking to make the operational shift from a mechanical-centric industry to a software-defined one? And how are automotive players looking to address the security risk? Now, these are some of the broad questions we propose to ask our panel of experts today in this roundtable on upshifting to the next-gen software-defined vehicle that is powered by our partners, MathWorks. Over the next 90-odd minutes, I'll try to assess and understand from our experts and get their views on the outlook, opportunities, and challenges around software-defined vehicles and the way they promise to transform the auto industry. And we're indeed honored to have with us five very key leaders representing the critical stakeholders of the Indian mobility ecosystem. Please join me in welcoming Mr. Binoy Paul, Vice President, Mahindra & Mahindra Limited for the automotive, farm equipment, and agribusiness. Mr. Paul has over 25 years of industry experience, most of it in the automotive electronics engineering space. And currently he's leading the team at Mahindra's automotive responsible for electrical, electronics, and software product development. Please welcome Dr. Naveen Gautam, Managing Director of HELA India Automotive and eMobionics. Dr. Gautam is also the member of the Executive Board Business Division Electronics at HELA GmbH at Lippstadt, Germany. Gautam is an expert in vehicle electronic development and vehicle EE architecture design and has over 30 years of experience in the academia and industry worldwide. Our third guest today is Mr. Prahalada. He is a president and client partner at Tata Technologies. He's also a native product strategist, building global organizational PD capabilities and digital transformation. In addition, he's a convergence and integration specialist where customer, product, and digital technology mesh. Mr. John Lee is a senior consulting manager who has worked with customers in the automotive and commercial vehicles industry to address embedded controls and embedded controls development challenges and implement model-based design. Gentlemen, welcome to this roundtable today. My name is Deepangshu Sarmah. I'm the editor of Mobility Outlook, India's first and only media platform that takes a holistic approach to the mobility ecosystem, and I'll be the moderator of this. Now, before we proceed with the discussions, please allow me to introduce and welcome Mr. Sunil Motwani, Country Manager, Sales and Service, MathWorks India, for his welcome address. Sunil has been at MathWorks since 2008, from the time it started operations in the country. Sunil?
Okay, thanks, Deepangshu. Very, very happy to be partnering with Mobility Outlook once again to host a roundtable like this on an emerging trend in automotive industry. Thank you, Deepangshu, for partnering with us on this and for hosting this roundtable on your platform. I'm very pleased and honored to welcome all the people who are attending this roundtable today. And many, many thanks to all the panelists for taking their time out today to enlighten us on a mega trend in automotive industry called software-defined vehicles. MathWorks, as you all know, is the maker of MATLAB and Simulink. Over the years, our tools have been extensively used by automotive industry for embedded software development. And we certainly collaborate with industry leaders and thought leaders in automotive ecospace to understand the challenges looking ahead for future generation vehicles, and also to find out how we can address those challenges. As part of this initiative at MathWorks, we have been hosting such roundtables in India for more than 2 or 3 years now. And Deepangshu has been moderator for all of those roundtables that we have hosted. In the past, we had 3 in a series on automated driving and driver assistance systems. This time we thought we would touch on a different topic. So along with connected and automated and electrified vehicle, software is becoming an integral part of modern vehicle. And as Deepangshu mentioned, we have tens of millions of lines of software code running in today's vehicle, and probably would go to hundreds of millions of lines of code in future. Much more than what an aircraft today has as embedded software lines of code running on it. So our future vehicles are going to be software defined to improve the user experience. No longer we would be driving away from a showroom with a car with fixed set of features. We would driving home a car or a vehicle which would see more customization and enhancement of features through its life cycle. And as a user, we would benefit from enhancing our experience with the same vehicle over a longer period of time. It's a mega trend in the industry. Every business leader is talking about it. And I'm sure every one of you who has joined this discussion online today with us would be looking forward to hear from business leaders like Mr. Binoy, Prahalada, Dr. Naveen, and my colleague John Lee, who is joining us from our Novi office in Michigan. Once again, thanks to all the panelists, thanks to Deepangshu, and thanks to all of you who have joined us. Wish you all a warm welcome to this event. We are going to see nice thoughts and ideas emerging out of today's panel discussion, so that we all are together in addressing the challenges that software-defined vehicles will pose to us going forward. Thank you and warm welcome.
Thank you. Thank you, Sunil. We truly appreciate MathWorks' support in putting together this roundtable. Ladies and gentlemen, before we begin the discussions formally, I would also request our honored delegates today to actively participate in this discussion and ask and post your questions to our panelists using the Q&A box that you see at the bottom of your screens. And I shall try and take them up in the final round of this discussion. I'd now like to welcome each of our panelists to make introductory comments on the subject of the discussion, and would request you to all to limit your comments to a maximum of 2 to 3 slides or maximum of 5 minutes. I would like to begin with you, Binoy, for your initial comments.
Yeah, sure. Good afternoon. I guess good morning, early good morning to Mr. Lee, and good afternoon to everybody else, I guess. It's always good to be on a panel which Deepangshu put together. He always picks a very innovative, interesting topic. And I never thought when I started my career in India on automotive electronics that we will be talking about software-defined vehicle in 2022. I'm a software engineer to start with. So as an automotive software engineer, software was such a small piece 20 years back. Now we are saying software is defining the vehicle. There's no better thing to happen in my career than this. That growth of software and importance of software in vehicle is such a great opportunity. And speaking in terms of India specific, we are sitting together like this and talking about an emerging trend, and implementing that in India itself is a big positive for me and for all of you. We are no more a follower market. That's a big statement to make, and I think we are now in a position to make that statement. So I'll start with a few slides and then we'll get into discussion mode. I just put together some thoughts as slides, take you through that. So this picture which you see on the bottom, is this whole screen visible, Deepangshu, or is this?
Yes, it is visible, Vinod.
Okay. So this picture which you see in the right corner is the wiring harness diagram of XUV700. You can see the XUV700 is Mahindra's flagship from an electrical electronics perspective. That's our current top-end platform. And this is the complexity which we have. It has around 30 ECUs spread across. Now, what is the architecture behind that is this. We have multiple ECUs connected over CAN, domain centralized, we have domain-based architecture, and then there is a gateway which makes it talk to each other. And this is a platform which goes into 7W and now the Scorpio N. The domains are standard domains, powertrain, body, connectivity, and autonomous. Now, what is the future in vehicle architecture? So I'll start with vehicle architecture and then get into software defined, right? So these are all statements which we are all aware of. Software is going to dominate the innovation and the differentiation of a product. E&D architectures have to adapt to the need of a software defined vehicle. So there is a thought process which I would like to stress upon. The whole E&D architecture is a necessity because vehicles are becoming more software defined. That's the way I want to see this, because the customer drive is to get more features, on the go features, differentiated features to enable, and also cloud native features, right? To enable that software differentiated feature to my end customer, what is needed is a software defined vehicle. And to get a software defined vehicle, we need a centralized architecture in the compute. And the compute's capability today is allowing us to get into a centralized architecture. So that is the evolution of E&D architecture, and it's not the other way around. Okay, that's one fundamental point about why these evolutions are happening. So the E&D architecture will evolve to achieve this, and as we mentioned again earlier, the product doesn't stop at SOP, the product life starts at SOP, right? So the feature of the vehicle has to grow as the customers use it, and as the customer's need changes, the vehicle should adapt to his new needs. And that's possible only with a software-oriented solutioning. If it is a hardware-oriented solutioning, it calls for a lot of rework of the vehicle or a lot of re-adaptation of the vehicle, whereas with a cloud native and a FOTA oriented architecture, software deployments become easier, and it gives you the differentiated features for the customer. So that's where the genesis of SDV is, in a simplified way. Current generation vehicle softwares are contained within the ECUs, monolithic. It is not, it talks over CAN or at the maximum on a high-speed networks. It creates its own monolithic structures. It is not easy to deploy across. So that's the current situation. Functional orientation is limited to domains like an ADAS system will use a display to show what it is, but it doesn't use that compute power of a cloud to enhance it, right? Or the compute power of a cockpit domain to enhance those features. So there is a restriction to the amount of collaboration possible between ECUs. The future is centralized compute and zonal controllers, wherein we can have microservices deployed. So there will be, in the software architecture, you have the BSW, ASW split, which is the historical split. Now in infotainment domain, we always went into a BSP, middleware, application layer, HMI layer, architecture, and that's becoming the bigger overall software architecture. It's getting much more layered, and the top layer of applications becomes deployable across. The microservices is a word which is very well used in cloud. You guys who are working in cloud will appreciate that. And now imagine that microservices approach coming into the edge of the vehicle, and also agnostically deployable across cloud and edge. That is where the software-defined vehicle will become more valuable to the customer. So there are multiple ways of doing this. Multiple OEMs are doing it in different ways. I would not want, no, we can delve into that during our Q&A. But in general, this is how it looks. There will be cloud, there will be high performance computers, there will be zonal computers, and then smart sensors and actuators. This is again common industry knowledge, but this is what is helping enable a software-defined vehicle. There is always a discussion about what is the benefit. Yeah, we reduce the number of wiring harness, number of ECUs, the length of wiring harness reduces, the weight that reduces. Those are all immediate advantages to the vehicle. But the bigger advantage is the customer, the continuous deployment of features which customer gets, the configurability the customer gets, the flexibility and the differentiation which the end customer will achieve because of all this. One thing which is very integral to software-defined vehicle is how you deploy, right? The DevOps methodology has to come into automotive. It is there in bits and pieces, but it has to become an underlying fundamental principle of how we develop and deploy solutions and features. I don't want to use the word software a lot. The word should be customers' enjoyable feature enablements. And how do I do that on a continuous basis? For that, a DevOps approach is the right solution, which again is an adjacent industry we are to leverage from. The mobile industry or the cloud industry, everybody are in DevOps. Agile and DevOps is the bus, and that has to get deployed into automotive. It's happening in bits and pieces, but it has to become the standard. This is just a view of how OEMs are coping with it. Software-centric development, software as a core business is the ultimate goal. The automotive companies becoming software companies, right? In a way, because that is where the software-driven vehicles will drive the organization to. So software-defined vehicle is not necessarily only an engineering topic. It's also an organizational topic. And it's an industry topic because it's a way we communicate the product to the customer, the way we manage the product, the way the customer uses the product, all of that changes. So software-defined vehicle is a big shift in the way automotive industry will work. The fundamental principles are on the engineering and how it gets done and number of lines of code and all that. But the bigger picture is how do we convert ourselves or how do we evolve ourselves into a software-defined vehicle-based industry? No, so there are multiple ways of ownerships. And as Deepangshu was mentioning, is it completely owning yourself? Is it with partnership? How much you want to own? How much you want to partner? How much you want to work together? There are multiple OEMs coming together to work on it together because it's a big task in your hand, right? So there will be consortiums, there will be standardization which will be needed around this, and that's in the works. So it's an evolving area, very, very fast evolving area, I would say, and lots happening, lot of action in this. That's just quick overview. I'll hand over to the next.
Thank you, Vinay. I'd now like to welcome Dr. Naveen Gautam. Dr. Gautam, your initial comments on the subject that we're discussing today.
We were looking at this at a very, very important juncture, in terms of saying that what is it in the automotive strategy and what is it that matters to OEMs, in terms of the value chain, where do we want to play? What is it that we want to pick up? How much of software or electronics that we want to play? So that was really a strategic conversation for a OEM. Several decisions were made at that point of time to look at whether it is a conventional IC vehicle or the EV vehicle, what part of the software we are going to kind of play on. And in that context, I would, in a way, be slightly contra to today's topic to say that I would still push for an auto OEM is still a vehicle company. I do appreciate Tesla. I mean, great respect to that company and, whatever Dr. Gautam was talking about. But at the end of the day, there is a vehicle which is moving on which the customers are on there, right? So I would kind of keep that in my mind all the time when I'm kind of discussing on this. And that brings me to the core of the logic or the push that I want to talk about, which is about customer-centric thinking. So a lot of us think that, it is software which is important, platform which is important, OTA which is important. That's fine, but I think at the core is a customer need, a customer requirement. So auto OEMs will look at how do they deliver more and more value to that part of the business, and therefore their strategic orientation is going to be centered around the customer sensitivity. So it will kind of drive down from that thought, as well as the thought that Dr. Gautam was making about the where do we want to play, in the full value chain. The other element that I want to mention in the discussion is that when I talked about auto OEs, he talked about tier ones, but I think there is a space for service providers. Okay, people like right now Tata Technologies play significantly with Tata Motors in terms of bringing value, not only Tata Motors and other Tata Group companies and other vendors to whom we service worldwide. So there's a big game that can be played by a company like ours in this value chain. So we need to think through to kind of get to that complete value chain, and it cannot be thought about in a limited perspective. And to kind of make a few points which I think are the bigger trends, and we talked about the over there base service model, which is the Tesla model also, and that model will get more deeper and penetrate more deeper. And I also think that how sales and marketing and customer experience in automobile will change, and it is going to change big way. It could be AR, VR, it could be a lot already. Many companies are experimenting on this. So therefore, the sales customer selling experience is disrupted. It is going to make a huge difference, and obviously all these things will be software dependent or software driven. And the last point that I want to make in the same breath is that I did talk about the cloud-enabled development. I think cloud will become more core to auto OEMs thinking as much as vehicles is to their thinking. So many strategies, including technology strategy, cloud strategy, will become core to the auto OEM strategy, and therefore, with that, how does the value chain behavior also start changing as we look at the disruption? We have many examples worldwide who have forged relationships and partnerships with several aspects of business. Indian industry is also kind of getting to that point where they want to make serious inroads in this thinking. So I think we are at that cusp, where we are all trying to figure out which is the best balance that we need to work on. The size of the point, Dr. Gautam used the word out of control, is so big. So we cannot let any system to be out of control. So there are spaces for everybody in the value chain to play with it and to bring this in control. These would be my opening remarks, and then we can go through the discussion to make it more clearer.
Thank you. So clearly there is an opportunity for everyone, and like you said, finding the right balance is going to be the key in the future. At this stage, I'd like to invite Mr. John Lee from MathWorks. Mr. Lee, over to you.
Thank you. Thank you, everybody. Before I start, just want to take a chance to thank everyone to give me the opportunity here to join this panel discussion. My work at MathWorks allows me to sort of look at automotive industry, not only from a North American perspective, but also across other countries. I definitely think this is really an interesting time, especially in India, with some of the software development and some of the mega trend that's happening within our industry. So again, thank you for allowing me this opportunity to have this discussion with everyone. Maybe just a couple of thoughts here. When I think of the software today, many of the items that the other panels has described, right? They're technologies that's coming online. Okay. My colleague Rashmi recently gave a talk at ET Auto Tech Summit, and she put together a really nice summary, right? Some of the technologies that's sort of driving our industry today, and most of these things that other has mentioned, right? A good example of that is the EE architecture. Okay. I was a software engineer when I first started. The architecture that I worked on is nothing like what we're working on today. Okay. And beyond that, right? Beyond the architecture, the AI workflow, connecting to cloud computing. And all of these technologies drives a new level of collaboration between OEM and Tier 1, right? I think Mr. Rao just also mentioned that as well. And in addition to that, all of these new technologies also requires us to making sure that the software we place inside the vehicle, because at the end, they will go inside the vehicle for user to experience, must be safe, right? Must be met the user intent, if you will. Which means that there will be more validation, more verification type of work. Okay, and I think this is where MathWorks will come in. And speaking from a tool vendor perspective, we would like to provide you with these tools, function, and feature as a way for you to design or to implement this technology into the vehicle. Okay, and just taking maybe a little bit different perspective. When I started working at MathWorks, one of my job function is to support the initial ramp up in China, operations in automotive company in China. And this is back around 2010 or 2011 timeframe. And I think everyone here probably could remember, right? During that time, there is somewhat of a transformation as well. During that time, hybrid vehicle, plug-in hybrids, and eventually going to EV are started coming online. So when we talk about these technologies, these megatrends, to me, it's really an opportunity for the new players to come in, right? And also to be able to compete with the established or traditional players, because it's a new technology that everyone is starting to the similar leveling, everybody that starts on a similar level playing field. Okay. Now, when I first visited China and talking to different of our customers there, when they start developing, we're looking into hybrid and plug-in hybrids, and EV for that matter. When I came back and many of our North American colleagues talked to me about what's going on over there. And, I was somewhat amazed by the amount of investments that the companies are putting in, and also the talent, the engineer that coming out of the school, the passion, the initiative to drive, right, to develop these technologies. Okay. My first thought is within a few years, the cars coming out of China will be on par with where the technology will be there, right, on par with many parts of the world. But it took longer than that, right? So that was a lessons learned for me personally, because I think it's important to understand how we can leverage these technologies and implement these technology to drive the vehicle forward today, right? But at the same time, I think there's a very important part, which is the process in which we develop the software. Okay, I think that's one area many of the company that I work with, especially in China, and to a certain extent, I'm also seeing a similar trend with the Silicon Valley startups, right? They're very good at looking into technology, getting the technology, using the technology to create a design, right? And put that function feature into the vehicle. They're able to understand that technology, create it, and show maybe initial prototype. We're getting the initial vehicle on the road. However, once that's done, at the end of the day, that vehicle needs to go on the road, right? And when that happens, you want to make sure that software was working appropriately or properly. And the moment that happens, more function and more feature, more requirement will come. Time to market shortens, more competition, right? And now everything just kind of starts to explode, okay? And I think to a certain extent, that's what happened in China as well. It took them some more time from a software development process perspective, right, to be able to manage that level of complexity. So to me, that was a lessons learned, because I think you can get a very good engineer, very smart engineer, to create the design that you put in the vehicle to demonstrate it, okay? But to put the software into a vehicle that can go on to production at that type of volume, you need hundreds of engineers to do very similar things, okay? And to do that, to manage that process is going to be very important. So maybe slightly different spin or perspective on the discussion today. In addition to having the understanding of the technology, I think it's also very important to make sure that as these technology matures, or as we develop our software, to have a process, or understand that process in place to be able to handle some of these things. Thank you.
Clearly, John, that's very, very important in the long run, as well as, of course, as we start working on such software. Thank you for your initial comments, gentlemen. We would now get into a discussion, and please feel free to sort of suggest subjects that we need to pick up along the way. But I'll start with you, Binoy. Let's start with one of the biggest, I would say, problem statement out there, right? It is often said software companies don't understand automobiles, and automobile companies don't understand software. Now, is that a thin line getting blurred as we make progress in this area?
That's why we are here. That's why the in between is important, right?
Right.
So I would pick on what Mr. Lee mentioned, right? I was part of that China story to an extent, and what he mentioned is very true. Now, having a lot of smart engineers who can develop software doesn't get you a software product. Okay, and a software product doesn't get you a vehicle. Okay, there's a huge journey in getting a consistently working software from the code you write to the code which runs on the car. So there is definitely a different amount of consistency, automotive hardening, if you want to call it that way, into the software. So a pure software company to become an automotive production-oriented software company, there is a journey. And a lot of the organizations are going through that. Okay. Now, architectures and this cloud native solutioning, microservices, standard APIs, platforming, all of that will help get the non-automotive software guys to play in automotive. That is the game which we'll see in the software-defined vehicle. Right? You get containerized package software. You will get appified, if you want to use that word, software components, microservices. That's a more technical word. So there will be solutions. So for example, I'll take an example of our own car, XUV700. You good to look at that middle screen and you drag the screen up, you see India Today app in the bottom. Now, the India Today app was not developed for automotive, right? It was developed for a mobile phone. Now, you deploy that in an automotive environment, you have to have a framework around it. And you protect that framework, and even if any particular issue is there, it doesn't affect the vehicle to be active, to be running. So that's the game in this. It is not that the software-defined vehicle field will be a platform where a non-automotive software company can also play, but there has to be a middleware automotive set of people who defines how it is played. Okay, sure. You cannot say no. You have to allow that standard software organization, software solution to come into automotive. It is the next screen. It is the next space where the customers are going to enjoy their life. You have to have those solutions come in, and how you get it done in an automotive way is the strategy in software-defined way.
Sure. Dr. Gautam, while this transformation promises to be very rapid, what are some of the key challenges that you think the industry will need to address in the short term? While we, of course, keep our long-term goals in perspective, what are those challenges that you see?
I think the biggest challenge which we see is the availability of the skilled resources. Traditionally, I would say in automotive, we always need a little bit longer time, especially automotive embedded software electronics is needing some of the framework and mindset which enable you after working a couple of years, then only you can start playing the real game. Compared to that in IT industry, you get in first 3 months, 6 months, you are ready to roll in. That doesn't happen necessarily so easily in automotive. And as market is quite lucrative, within and outside automotive industry, people are churning around. They call themselves board and specialized in area after working 6 months to 1 year. And this is, I would say, counterproductive for overall growth of the industry and also the growth of the country. So this remains on the framework. But when I come back what is the challenge within automotive industry, apart from the skill requirement and how we are systematically working on it, is the forceful fitting of the vehicle development and life cycle management. So the vehicle has a development plan. We start with concept and clay model, and then design verification, production tooling, production verification, all these milestones. And we try to force fit software development into it. And this is really not working out still. We try to do it, and we try to create our pseudo milestone and pseudo. So when you are putting some hardware, electronic control unit for vibration testing, and you say, oh, it is from the prototype tool. And then next time you do for the production tooling. And we do all these environmental tooling. And then in pseudo way, we are saying, okay, this is also our DV software, and this is our PV software. But software is a software. It doesn't go for production and development in a different cycle. It is just one cycle overall. So we need to have a carve out approach, and it has to be jointly agreed between OEM, tier one, and potentially maybe other partner, and create a parallel software development, and not only development, but life cycle management. Because the kind of feeling, oh, I need to release it. And when you to release a hardware part, you feel a lot of pressure because, hey, if it is gone out, thousands of car, hundreds of thousands of car, if recall happens, what happens? But then we have IoT for software, we have different way of mechanism where seamlessly things can be changed without anybody's knowledge. And if all those things are managed in a controlled way, secured way, and all the version control, then the anxiety before software maturities goes significantly lower, the sensitivity goes, and then we can do multiple iterative loop as we mature. And then we can also run up some of the software, some of the self-healing algorithms we can deploy, some self-learning AI-based algorithm we can deploy, which is not 100% software is going out at the time of launch, but you are learning and refining and fine-tuning as you are driving the car. And this mindset that software is getting developed as thousands of users are driving car in the field is still far away from our practical approach in the automotive industry. And I would say this mindset change, decoupling the software lifecycle management from the vehicle development and vehicle lifecycle management would be the biggest challenge.
Okay, all right. Mr. Rao, I'll also seek your perspective on this. As a services provider, what are some of the typical challenges that you see in this journey?
Yeah, so I want to kind of combine my view to the question that you posed to Binoy and what you talked about Gautam. So, he talked about the process, right, which I think is a very valid point. And in some way, Binoy was talking of technology, right? What are different technologies which need to be there? And your question to him was, will software companies be the ones who will take over this? But I think we miss the significant aspect of domain. Automobile and its work is a very domain specific kind of thinking, and it is not that this domain is so isolated nobody else can participate. It's not that, but where is the core is, I think, the question. So to me, the driving point of the core is the domain, and everything else kind of moves around the domain of the core, which is the vehicle development technology or vehicle development thinking. And in that context, what Dr. Gautam's thought about, how do you fit in? Is the software, can have a different development process? I think one of the key challenges that Indian EV industries you might have seen in the recent past has experienced is safety, right? So the issue about this whole customer safety, and that is actually rooted in the issues about certain software and battery management systems, etc. It is at the core of that. What is that which is happening in the EV vehicles? So I would pick up at the first, customer safety. There's one issue that the whole software development has to look at, and this aspect of safety has, I think, a big link to the complexity that which Mr. Lee was kind of alluding to. So many thousand and lakhs and millions of lines of code, therefore the complexity is higher. How do you test it? That problem is also there. When you look at these two and also look at customization, because the demand for customization, alpha release, beta release, what is that customer is going to look at? All these things of software and the vehicle will keep playing an interfacing role and a challenge. So for people like us in service providing, you can play in only testing, you can play in architecting, whichever way we deal with, whether if you just take anchoring of safety, that itself has many links that we need to deal with it in this thought. So domain is important, process important, technology, there's no question at all. But unless you kind of start integrating these things, I don't think so we'll have a coherent, comprehensive thinking to be put to the customer.
Mm, mm, mm. Taking on from there, Mr. Rao, what is the kind of preparation that you think is needed in R&D to prepare for SDV of the future? And how are our R&D leaders really looking into making this operational shift from a mechanical-centric industry to a software-defined one?
Yeah, so I think in some way the first point was anyway addressed earlier by my panelist about people and skills, right? I think that's at the core. I don't think so there is any demeaning in it. It's one of the key building blocks. When it comes to the shift, I think most of the OEs and whoever is there on the table, who are there at the forefront, have already made the shift. The decision making has shifted, the conversation has shifted, the the R&D boardroom thinking has shifted. So that's clear. You can kind of see that going through. But has it shifted enough, or is the perspective wide enough? Is the question. I think the interplay of what all is happening is reasonably complex. Even more evolved brains, I don't think so, are able to figure it out in any which ways to place where what is going to play out and how it is going to change. And it is also kind of challenged by another fact about pace of change. If you just thought that you would define something today, but after 6 months something else is changing, right? So do you have a view which is capable of taking care of the pace of change is also important. So I would like to put it at 3 frames. One, I think already decision makers are seized about the situation. They are thinking on this line. So there is no disconnect on that. Second one is that you can't in this world have a fixed frame of thinking. It's just relating to earlier discussion where you sold a vehicle and it was after that, if there were some problems, it was thought about. But you're not in that mode anymore, right? Your software which is being sold might have more developments coming up. So the thinking of what you are selling is also changing. And the Tesla example, which was there earlier. Yeah. But the last one, which is more important, is have we evolved frameworks and thought strategically enough to say that in the future we'll still be able to take decisions in the frame that we have talked through in the beginning. So all the three are kind of very important in my view.
All right. Thank you, Mr. Rao. Mr. Lee, at MathWorks, how are you enabling this change to a software-centric mindset?
I think that's a great question. Okay, so from MathWorks side, we're a tool vendor, right? Our goal is really to make sure the technology that we just mentioned, we have a way for you to realize that, right? A way easier for you to implement these technologies. Okay, taking the architecture example that many have mentioned, right? The architecture is different. Okay, it's a lot different than the distributed type of function ECU that I worked on many years ago. But that also means the modeling construct, right, for you to create that design is going to be different. And for that, we have developed additional capability in our tool to help you realize that. Okay. I think that's an important part. And having those capability inside your shipping tools allow you to do your job easier. Okay. I think that's one part, right? And the other part is the area where I worked in services, in that we can help our end users on how to best use those tools, right? We have a certain design in our mind when we develop those tools based on the use cases that we hear from industry, right? And so we build those in. So we would like to be able to share those as best practices, right? Showing you how to use those and getting your users ramp up quickly. Now, I think that's one part of it, right? And if I were to sort of going back to some of the lessons I have learned when I look at what China has done, and even today some of the Silicon Valley players are going through, okay? And I think others, right? Mr. Paul mentioned about the hardening of the software. I think that's a perfect term. Dr. Gautam, you mentioned about the life cycle management, right? And then Ms. Rao, you mentioned about safety. Okay, all those things are I think important things that users might not think of, right? The driver, the passenger, they're not quite thinking about on that level. They're looking at the really cool features that's in the car, right? All those personalization, all those function, all those capability, that's great. But behind the scene, as engineers, we have to make sure all those things are in place in order for that software to get on the road. Okay. So I think one of the things that from MathWorks side we also bring to the table is to be able to go in and look at the customer's development process. Okay. Also to kind of help them not only to make sure the technology, right, how to solve those technology issues, but the process they have implemented, right, can achieve sort of this hardening of software, if you will. Okay. I remember a very very clear example in my mind when I was working one of the OEM in China, right? In order for them to be comfortable, right, reduce the anxiety, as Dr. has put it, for releasing their software, they're going through and try to leverage ASPICE, okay, which is a great way for you to sort of reference, understand some of the best practices in there, and build that into your software process, right? But you know, it is important to not just reference ASPICE. It is very important to understand what ASPICE is trying to do for you in your development process. Okay, why do I bring this up? It's because just by going through some of the activities and tasks as required by ASPICE won't get you there, right? You really need to understand the essence of what they're trying to do. Okay, and to make a long story short, what happened is this particular company is able to get ASPICE certification. Okay, but at the end, the manager for the project told me that they will not use that process because not having a great understanding of it, meaning that they're doing things not in a very efficient way. So at the end of the day, having all these new tasks, doing everything on top of it, the cost for developing that software, the amount of people that are required to do that, it's just not possible, right? So from MathWorks side, you know, just to summarize, we can bring the tool, function, and features, right? The enabler for these technologies. But at the same time, I think we can also bring another perspective, right? Which is looking at how these tools can be fitted into a very efficient process, right? In order to meet some of the key terms I mentioned, the hardening of the software, the life cycle management, the safety aspect of the vehicle.
Right. Thank you, Sili. Binoy, I'll come to you. You know, when we look at a slightly long-term horizon, how do you view vehicles from what they are today to what they would become, let's say, 10 years down the line in 2032? What is in store for the next generation of vehicles that we would see on our roads?
Big one. So what again, from a software-defined vehicle, electronics architecture perspective, if I answer, what we will see is more centralized architectures, which means more and more software-defined architectures, more and more powertrain agnostic solutions. All right. Today we are talking about ICE to EV as a big transition. Now, an EV to what? Right? And what to what? Now, the drivetrain transformations will continue. There will be multiple drivetrains, but the customer experience will remain. Now, the customer use cases will remain. So the customer experience interfaces will evolve based on the lifestyle, right? So 2032, what is there in the car will be same as what they get in the home. You know, they will expect the same experience. You know, an autonomous vehicle, most probably, you know, will be driven around. It's an extension of his life. He will be watching the same movie. He'll be continuing the same meeting. You know, he or she will be, you know, sitting mostly in. There won't be a front row probably. You know, so all of that. The interior will change a lot. The drivetrain will change a lot based on the availability of the right technologies and the maturity of the right technologies, hydrogen and cell. We talk about a lot of that transition. So this will evolve and vehicle will become an extension of your lifestyle. This is the if I look at the 10, 15 years, 20 years down the line, that's what is going to happen. And that is what the journey we are on today, right? That is a journey we are on, and that will evolve, and the software defined vehicle will continue to be the relevant trend even then. That is only constant I can see, right? All those features and all those functionalities will get enabled by software, and that may be AI, that may not be coded, that may be evolutionary. The software may keep changing by itself without a SOTA. Right? These are all future trends which we can say. But software as an enabling factor to the customer experience will continue. This could be the best way I can package that view, but it's an unknown territory which we are getting into. And as we discussed earlier, the best foot forward we can do is to establish systems and processes and organizational cultures to ensure that we get the right product out there with the right quality consistently, and enhance the customer experience. If that will remain as a goal for us as organizations, right? And as engineers. And the engineers are not going to become irrelevant. I see a lot of chat box questions where what is engineers going to do? Engineers are always going to be there. Engineers make the world. That's what we are all here for, right? So that will continue. We will continue to evolve in our roles. That's why I see it.
Sure. Dr. Gautam, what is the level of commitment you think the industry is willing to make towards in-house development of software, or do you think that stakeholders would prefer to have closer partnerships with relevant companies, be it the software companies or tier 1 suppliers? You're on mute. You'll have to unmute yourself, Gautam.
Yeah, I will answer your question, but if you allow, I can make short remark on your previous question, because
sure,
it was a very thought-provoking question. So I would certainly agree with what Mr. Binapal is saying about how it will see, but I will still cluster maybe 3 categories. How the market is going to evolve, I would put into 3 different buckets, and they are quite significantly very, very different. So one category of the vehicle will be purely used for the goods movement of the goods, and that would not have any user experience. That is purely autopiloting mode. These are robot cars running around carrying the things, because significantly e-commerce will jump to the next level, and the personal experience sitting in home, selecting item, touching, feeling, even smelling them can come to the level where you don't need to visit so much stores. And then these delivery vans will be running around on the road. And this kind of one automotive class will be a significantly different, where autonomous driving and then the delivery secured way, taking in and taking out the goods will be the main function. So that's how we will see in 10 to 15 years, a significant portion of the automotive industry catering to that class of vehicle. The second category of the vehicle will I call is the people mover. This will be less of the individual own car, though there will be a personalized experience you can create as you get into the car, and your car is synced with your mobile, and one will be a lead family member, will have that possibility to do it, but still it will be a lot of shared mobility going in that direction. But yeah, again, lot more to do with you have a cockpit of future. The car will be driven and the class of the car will be driven. How the cockpit of the future, again, not having a driver and co-driver seat, but all the front and rear facing as a family room environment, and who is doing all the dirty work behind how the car is getting propelled is none of their business, because they are cutting completely soaked into their activities, what they were continuing from their living room to into this people mover room, which is their living room, just kind of put on the 4-wheel, and it is taking them somewhere. And then still there will be third category, which could be maybe 10-20%, where people will still talk about driving experience. That means they feel car is something which I want to drive and I want to feel and I'm going to experience. Naturally, the challenge will be more when IC engine, because we used to spend a lot of time in tuning the engine to create a nice sound. Now in the electric vehicle, 10, 15 years later, that sound becomes a different enemy or the entity where you need to even create it artificially because it doesn't generate. But road dynamics and all other topic and performance and speed and acceleration, maneuvering, and all those factors will be still important. But in this third category, which will be maybe maximum 20% of the vehicle will be sold under that category. And there the vehicle design user-centric approach will be different. That means you will cater 3 independent category where the driven needs are completely driven through their users. Now I come back if you are okay to your
Sure, please do.
question. And your question is how the overall ecosystem partnership with the other companies.
Stakeholders, yeah.
So I would see that the consolidation of tier 1 will be bound to happen very soon. It's already in the way. I personally experienced Hella being recently or sometime back acquired by Forasia. Now we are Forvia Group. We were 24th in the world and Forasia was 10th, and now we are 7th, going to be a 33 billion euro company soon in few years, already 23 billion now. But this consolidation is going to happen. And what driven? I mean, I need to ask myself, what has driven? Because one company has an advantage or relatively ahead in software, in electronics compared to another. So we are seeing much more merger acquisition going forward in next 5 to 7 years in the industry. And those merger acquisition will be defined by the mega trends. And certainly electronics and software will be a major chunk as a motivation towards these consolidation. This consolidation will also happen in OEM industry. I'm nobody to comment there, but as I see the trend, some industries are 5 to 7 years ahead. And I would here again name Tesla, even compared to their nearest neighbor, which can be counted as their in-house software capabilities. They are 5 to 7 years ahead. And 5 to 7 years ahead is a long time now, at least 1 generation of electrical architecture and 2 generation of the car development cycle. So that is the lead. And then consolidation will happen around the technological edge. I mean, we see the outrageous market capitalization of some companies over another. So I think the purchasing power into the equity market will be significantly different. But coming back to that, what it will drive? It will drive that software companies will also try to acquire one or another automotive tier 1, or tier 1 will try to acquire one or another software companies which are on the startup phase or not in the startup phase, but maybe an early market capitalization. And this will drive synergy. What they do not have, they will try to create. So the partnership model where we say a very open-ended consortia type of environment, I do not see that as a reality in the automotive industry as such, because automotive industry is still one of the more conservative industry, but a lot of consolidation will happen. Still, I see a space, a very clear space for application developer, and these application developer will be freelancer who will be catering to the need with the defined interfaces, and they will put everywhere. And I'm not talking here about only on the info entertainment system, but a unique way of identifying the key inside the car and exact positioning, and also checking the heartbeat of a person. And this app can be developed so that you can do all SOS call and emergency services and many more features for the smart car access and theft protection and security. And these app developer will come in play, and they would be largely from outside automotive industry, and they will play a significant role in next 5 to 7 years. And this role will be to large extent decisive in creating a competitive edge, because many other factors due to the complexity will be surfaced out, and anybody who can take advantage of this one will be in a leading edge. But if we are not able to manage, and that is going to be another phenomena which I can foresee, if we are not able to manage our thing, then a hero becomes zero very quickly. So far we have seen an evolution. Somebody reached to the top, and by the time they start coming down, it takes long time. But now with this phenomena, where security, this safety and all those aspects are playing role. And if you partner with the wrong one, very quickly you can come down down the hill, and then this can be a very, very difficult recovery.
Right.
One more thing which I would just last point make it here, that in ecosystem so far in India, academia is not playing a visible role. But I see that as a government might open up for foreign educational institutions, and when they put their own independent seat center, they will also act as a research development center, and these will be much more professionally involved into the automotive industry ecosystem, and then a lot of research might come from that area. This is my thought and even wish. I hope it will come true.
Thank you, Dr. Gautam. Now, my next question is both, for Binoy and Mr. Rao. Is it possible to think of a standard, let's say, open technology platform for software solutions that is modular and one that can lead to strong software integration across all vehicle domains? Is that already happening, or do you think that is possible in the long run?
So I was about to comment on that to Dr. Gautam's comment of standardization and so AutoSAR happened. CAN networks happened. Yeah. Ethernet, automotive Ethernet is happening. So standardization is possible in automotive. It is not as easy as other industries. I agree with Doctor on that, but it is possible. Yeah. Now there is adaptive AutoSAR discussions going on. Yeah, and adaptive AutoSAR by definition is adaptive, right? So so that is the level of flexibility we are keeping in that standardization. Now, to your question, Deepangshu, it's a challenge, which is Doctor was also referring to. But platforming will happen with some evolution. Like, for example, what happened in infotainment systems today? A lot more are going into an Android-based infotainment system. That was a big player making that happen, right? And now we are there are apps getting deployed. People are developing apps for automotive, Android automotive, which can be deployed. CarPlay and Android Auto also created an opportunity for apps to be defined for automotive, right? So there are some strategic, situation, some solutioning which happens, which makes you standardize. Okay, that is one way of standard. That's an accident in a way, if you want to. By definition, standardization happened with AutoSAR, right? It took a lot of time. It was not easy. Okay, it took a lot of time, but probably today the advantage is that we are becoming a bit more closer to the adjacent industries. We are not far away. So we are influenced by cloud. So I mentioned microservices in my proposal or thought, which is a very, very evolved solution in cloud. It's doable in automotive. It is doable in automotive without creating an automotive quality concern. That is what I mentioned earlier, that create the right APIs, create the right framework so that you allow everybody to play. Non-automotive engineer can also play, so that standardization will happen. It will take time. It is not, today there are multiple standards being discussed. There is SOFI consortium, there is Converser consortium. There is multiple API definitions. So these are all boiling down to API definitions. When it comes to software standardization, it's all about API definition. How do you define API? How many API? How varied APIs will you define? What is the performance parameters to that? There's a lot of work to be done. It's not a flick of a button and it will happen. It will take time.
Sure.
But it will be faster. In my assessment, will be much more faster than what it took for us to get into an AutoSAR world.
Sure.
So I think the comments in the past are quite valid. So let me take a dig at it in a specific way. In everything that we discussed in the past about your earlier question also, I think India-specific environment definition will pose significant challenges. So autonomous driving, for example, has been pointed out by my earlier panelist, but its acceleration, I think, is a India environment dependent issue. So I think we should be very conscious about India specific solutions or India specific emergence versus other parts of the globe emergence. Now to your question, and I would kind of put it this way, that some OEMs like Tata Motors are at the cusp of thinking through how this whole, whether it is open source or platform in platform, platform of platforms, such thinking is going on right now to kind of get to a definition. Now, at that, there are, in my view, some maybe 3, 4 we can define numbers. One is at the chip level. Okay, so there's a lot of software which happens at the chip level. Some OEMs have thought to discuss at the chip level also, NVIDIA, etc. There is a choice to be made. Many people might not make that choice as the part of the OE. The other choice is at, let's say, the infotainment level that when I was talking about. Whether the OEMs look at apps level definition and that their participation, they could create a framework and then just kind of live it, in an open way, but to make sure that whatever revenue, etc., can be properly tied to the thought that which is there. So Tata Technologies has been, championing the cause to say that we, as service provider, can look at integrating this for the OEM. So there will be a layer which is not at the app layer, which is not at the chip layer, but the mid layer where the integration thought has to be embedded with the OEM, and people like us who are service providers can play this role because OEMs could focus on few other things than this thing. So to my mind, your question of outsourcing, first to define these levels of layers and where to play and of which whom will you partner. These are all decisions that OEMs are making right now.
Okay. Gentlemen, we have roughly about 10 minutes. I would also take some questions from our participating audience today. But one final question before I go to the audience to Mr. Lee. Could you share some of the industry insights? Because you, as a consulting expert, you of course continue to meet a lot of organizations. Some industry insights that you can share on automotive software development at this stage.
So that's a good question. If I look at what we have learned, from other industry, if you will, right? That we have taken. I think one of the biggest things I have seen, and that was mentioned, I believe, in Mr. Paul's earlier talk, is the agile, the DevOps type of workflow. That has always been discussed, I would say, many years ago, but never really put in practice. Okay, but as the technology evolves, right, we're also learning to use these technology to design the software. So when that happens, how far the technology can take us and what we want to build in a car, is somewhat fuzzy, right? We're still learning as we go, and the traditional, the waterfall type of workflow doesn't quite suit sort of these type of development process very well, right? It works really well when you have legacy, if you will, type of vehicle design where you can make few 20-30% type of modifications and you can move on, right? But I think we're in a totally different world today, where some of the agile principles, if you will, of embracing the basic principle, embracing requirement changes, right? Making quick sprints so we can get evaluations out quickly, get quick feedback. I think those are going to be very important, right? And what I've seen recently is the automotive industry is definitely adopting some of those practices, right? So not only do the technology changes, right? The way we build our software is changing, and the process around that is also changing. So I think that is probably one of the biggest things I have seen brought into the automotive industry.
All right. Thank you, Mr. Lee. At this stage, gentlemen, I'm going to take some questions from our audience. I'll start off with the first one from Muzaffar Ali Sheikh Ji. He wants to know, do you think the Indian automotive ecosystem can innovate to tap opportunities that are offered by software-defined vehicles, such as over-the-air update enabling new aftermarket revenue opportunities? Is the regulator aware of the potential that these systems offer and is acting as an enabler? Can I take this to you, Vinod?
Yeah, I think it's not a future, it's a current state of affairs. Right? Connected car is a current state of affairs in India. We have connected cars on the road. Right? OTA is happening, but not for all its use. There are some vehicles which does OTA. So it's already happening. The answer to that question is it's already happening, and I don't necessarily see an acceleration needed by regulation here. It is a customer and market-driven requirement. No, it's not a regulatory topic. It's a customer convenience topic. No? And OTA is also misunderstood sometimes. OTA is, there were some questions about why should there be monetization of OTA. OTA for bug fixing will not be monetized. Yeah. OTA for adding features and increasing customer convenience would be the monetized factor, right? OTA by itself is not for monetizing. OTA by itself is to create a post-SOP flexibility for the OEM and the ecosystem to evolve the product. That's how you should look at it. Same as mobile phones. There's a lot of comments about mobile phones and cars. Similar to mobile phones, right? Not to that extent, but because of whatever we discussed earlier, the automotive needs some more hardening. So that hardening piece is always critical. Now, this is again, I will relate this to semiconductor industry. Semiconductor industry, what are the chips designed and produced for industrial grade, automotive grade are different. So software also, you have to follow those kind of, it does follow, and people have not understood in that way. But the current automotive software versus other software, the methodologies, the philosophies are following those hardening requirements. And yeah, it already happening. So it's not a future question.
Yeah, like you said, I mean, a vehicle that will be constantly optimized in the future will surely throw open a lot of opportunities for everyone.
Yeah, yeah, and that is the platform where a lot of ecosystem players will also evolve.
Correct. Yeah. Mr. Lee, I'll take this question to you. Ajinka Parab wants to know, what's the mix of edge and cloud computing applications for software-defined vehicles? What is the trend? Will edge computing dominate over cloud?
So that's a good question. I think, I don't have a good answer for that right now. I think part of it is because the technology is still evolving. Okay. And at this point, if I think about everything I thought about 6 months ago, it's probably wrong with how fast everything's moving, right? So it will be hard for me to make some sort of a prediction around that at that point.
Okay.
I don't know if other panelists have similar thoughts on that or experience in that area.
Yeah, my answer to that question would be whatever is real-time critical will continue to be an edge, right? That's a standard definition. Whatever is computation intense will go to cloud.
So this is a complementary. Now we are not talking about two
complementing.
Yeah, they are complementary, and then they will coexist. Only thing is based on the use case, one will dominate, another will supplement.
Yep, exactly.
Right.
The big thing we need to remember is that the cloud is not only infotainment, cloud can be for everything. That is the key difference which will happen in the vehicle when it goes to software defined. Today, cloud is considered an infotainment topic. Cloud is not an infotainment topic anymore. That is the key difference which is happening. That is what Mr. Lee is also telling, it evolves. As the cloud emerges, as the connectivity becomes better, as it becomes more, like 5G with V2X, CV2X technologies coming in, the usage of cloud will go up. But the dominance or not dominance is not a question to ask. It is the choice of where you deploy based on the use case.
Right, right. I have another question from Mr. KG Satish. He basically says for any OEM, practically it may be near to impossible to have complete inbuilt solution for meeting complete software requirements. Software being the most sensitive item, how far OEMs will be strategically prepared to outsource the services? Binoy, I think that's a question for you to answer.
So the way I answer this would be, see, today I said in XUV700 we have 30 ECUs. And if you're a software-defined vehicle, I may have maybe 10 ECUs, 6 ECUs, central compute. But I may have 50 more software suppliers. Today I don't have software suppliers as an OEM. But in future, when you're a software-defined vehicle, you'll have software suppliers, which means an IP provider of software becomes my supplier, right? So the question is answered that way, like partner. It's not an outsourcing topic. It is a solutioning topic. A solution will be owned, can be owned, a feature can be owned by a software company, like an ESP is today done by, let's say, a Bosch. A software will be owned by a software company. For example, again, Alexa, which we have integrated in XUV700, is not something we developed, nor any tier one developed. It is developed by Amazon. We integrated it. So Alexa is owned by Amazon, which is a software company for me, right? So again, it's not a future topic.
Yeah.
So to me, this whole value chain is not very clear right now. Okay, but one thing is clear, that everybody has play in this and an opportunity to actually add value. So we should not look at this as a very fixed system, where earlier, you had an engine, you had fuel system to be bought by somebody, something like that. This is a evolving thought. Software defined vehicle and those platforms have multiple opportunities for multiple players. So how innovative you are to add value, that is what will be giving you the right on the table. That's it. It is not anything else. It's not like whether I want to transact that value as a OEM, or should I give you that value. If you are innovative, you will be at the table.
You'll be at the table. Gentlemen, what we'll do is we have roughly about a minute, but I'm going to extend it by a couple of minutes to get your final comments on the subject. So when we look at, we've had a very engaging discussion today. I didn't realize how time flew. So your final comments on the subject as you look at SDVs in a short to mid to long term, in very, very quick, let's say 1 minute each. I'll start with you, Mr. Rao.
You're on mute.
Yeah.
Sorry. So my view is that, I will continue my earlier comment, that the CAGR of what is going to happen to this industry is definitely more than double digits. It's really, really accelerating, right? So whether you look at connectivity, autonomous vehicles, or ACE vehicles, or whatever you want to define, opportunities there for everybody. Of course, OEMs, to my mind, will still anchor the value, and that's rightly placed. There is also, of course, a great play for the tier one suppliers. They are also greatly placed in this value chain. But there will be emergence of different types of service providers in the value chain, and all of them can continue to get better value from this. So whoever thinks innovative will make more money.
Thank you. Dr. Gautam, your final comments.
Yeah, 3-4 points very quickly. One is simplifying the software complexity to the level where interfaces are more clearly defined and it is published so that it is not a very IP driven interfaces. Second thing is very clear cut, and this is important, very clear cut decoupling the hardware development along with all the mechanical things with the software development as a life, not only the development, but the full life cycle management where flashing over the air and also enabling feature and learning them as you go forward in the vehicle. And third thing, which I would say also thought process in the background, considering the semiconductor industry crisis and also going forward many more crises, decoupling hardware to the software. That means microcontroller and driver independent software development, which you can very quickly stitch together and recreate multivariant, multi possibilities as a flexibility. And that could be the winning strategy going forward.
Wonderful. Thank you. Over to you, Mr. Lee. Your final comments.
Yeah, I think as I mentioned before, this is definitely an exciting time with our industry going through such a big transformation, right? And it's a big opportunity for many new players coming in to develop, either take on new projects, new products, and new business, right? It is important to focus on technology, understand what it can bring, but again, at the end of the day, the software needs to go into the vehicle, right? To be able to manage that level of complexity, safety, the life cycle, everything. That's going to be a key that distinguish between, ability to launch one vehicle versus from the long term, be able to launch a whole product vehicle line.
Right. Binoy, final comments to you.
Thank you, Deepangshu. So I would address this to the attendees mostly. I think there's a lot of opportunity for all of us to work together. Software-defined vehicle is an opportunity for India. Okay, we are, as I started my talk, we are able to innovate early. We need not be following. As an Indian OEM, as leading the Indian OEM journey here, I would say this is a huge opportunity for the entire Indian software ecosystem to work together. And every part of automotive ecosystem, partners, tier ones, tier two, dealer networks, everybody becomes software centric. When we go to software defined vehicle, it's not a software in the car only topic. It is software as a business model. So it's a transformational topic, and I think we are well positioned to be leapfrogging in it. And I look forward to doing that along with all of you. Thank you very much, and thank you Mobility Outlook and Deepangshu to be organizing this roundtable. Very relevant topic. Proud that we are having this discussion at this juncture. 2022, we are doing software-defined vehicle roundtable. Deepangshu, you mark it. It will be a milestone in our industry.
Wonderful. Thank you. Thank you so much, Binoy, for those kind words. And gentlemen, thank you for being part of this very interesting discussion. I just wish we had more time and we could continue talking about this subject. There were a lot of questions that we had. Unfortunately, we couldn't take many of those questions from our audience today. However, I truly appreciate, I'm sure everyone's going to go back richer from your perspectives, from the knowledge, and we truly appreciate you taking time to be part of this today.